Good afternoon, class. Today we will see the next topic in the second unit. There is a data flow testing. So in previous sessions, we have seen control statements and then transactions. The flow graph, which is representing the control statement, which is the control flow graph, and the transaction which we are representing is being specified as a transaction flow graph. In this, we will study about the data elements. The data elements, what we are using, data elements for what we are processing, and what is the consideration of these data elements, how far they've been specified here. Means whenever we are when we are accessing about these data elements, we need to consider that we need to read we need to study about the each and every data element what we are having. Means the data elements what you have been used, that is what you have been specified to be used, that is defined, used, or any such representations has been fulfilled throughout the program or not. All the elements what we are represented has been used thoroughly or not has to be represented here. So how we are going to specify what makes this one has specified here is, if you are considering any statement, any set of the statements here, so let us specify a and b. A, B, and C are the elements what we are chosen. So I am writing this for the sum of given variables. Okay, so I choose some variables here. So what I am doing is I'm assigning some values, and then next I am providing the operations of usage here. Coarsely I'm writing the program. So this is the end of the program. If you see here, so we need to study about the data elements here. So the data elements what we are having are A, B, C, and D. Study about these elements means A has been defined. Yes, A has been defined and it is being used. How far it is being used here is, we represent it in C is equals to A plus B, and B also defined here. And we used it. C also defined here, and it also used in printing a statement. And coming to the last one, that is a D, it is being just declared. It's not been used or it's not been considered for the processing. Okay, so here in this representation, we will see whether we are providing these things or not. Means, for example, see here, ABCD variables, these two are defined here. So these two are defined, and then these two are used here, and C also used in this representation. But this D, what you are provide, has been specified as a declared only. It has been used. So what it is saying, each and every value what it is being defined has to be used once. has to be used once, and what we are specifying, what we have been producing the value has to be considered in at least one computation. We has to specify at least one computation. If you fail to fail it if you fail to specify this one, means print, just if you fail to specify this print C, then what happens here, whatever you are defined one and then next computational one will not have any meaning for processing. End of the program is you have been used three such different variables, and then next two are defined, three are been third variable is defined by using the above two, and the third remains fourth one remains as a undeclared only, undefined or the unused there itself only. So what is the belief here is, we need to consider a statement, or we need to consider anyone which includes the data variables at least one usage. Means the usage could be, the usage what we are specifying could be computational use or the predicate use. Predicate use means this could be in a that is a control statement, like that it is specifying. So by that we need to study about each and every data element what we are having. How I am going to study about this means, we need to take the flow of the data flow of that representation. Here we are having the two basic machines for processing. One is the von Neumann, and the next other one is the MIMD and SIMD. So von Neumann machine architecture is a earlier one which executes one instruction by another instruction. Only one instruction will be processed at a time, and meanwhile there is no other processing will be done here. How it is going to be executed here is, first it will fetch the instruction from the memory space. Let us consider the previous only. So here the previous means I am taking the values A, B and C, and then next A equals to 1 and then B equals to 2. A equals to 1, B equals to 2, and then C is equals to A plus B, and then print C. And the last one is the end of the program. So here, how we are going to execute this one, fetch the instruction from the memory. So first I need to fetch the instruction, which one, first one, what you are representing here is the ABC. I want to fetch the instruction. Interpret the instruction. Interpreting means here I need to study about the this instruction. So what it is here is, it is three variables of integer. Okay, that is the one. Next, fetch the operands. So what are the variables we are having? A, B and C. So here what is the execution here will be done means, they have been declared as integers, and a memory space has been created here. Okay, and then next we need to take another one into an account. So that is the next one, next instruction. That's why we need to increment the program counter, and we need to go for the first instruction we have been started. So here, so what could be the next step? So here, fetch the instruction from the memory. So the instruction here is A equals to 1. Interpret the instruction, store the value which is 1 into the space of A. Okay, next step, fetch the operands Operand means there is no such no operation or the processing is there. What you have to do, we need to simply store that one, and then processing will stop there. And coming to the b equals to true, also that one. And then next third one, c is equals to a plus b. So we need to add two such variables and store it in C. Okay. After that, what you have to do, we need to perform the operation. To perform the operation, I need to fetch the operands here. So what are the operands I am having here? A and B. I need to process. Process means perform, add on A and B, A and B. That's all. In the next step, I need to store the result where in C. So after that, I have to go for the next one. Likewise, I will perform the instruction set processing here. So this is for the things what we are doing, what we are dealing for the one human architecture, which has been executing single or the one instruction at a time. If you go for the next, in the modern days, what we are using is, we are using multi-instruction or multi-data machines, or we can specify SIMD also. So these, what you are doing, these will fetch several instructions at a time. On what we are doing, how we are going to process here is a parallel processing will be constructed. Parallelly, what it is doing is, it is executing all that one. It will perform different data objects, and then next, it will store the data which is been parallelly processed. First, we need to identify what are the instructions need not to be depend on each and every one, has to be identified, and we need to perform them parallelly. So after that, we will compile and we will get the result there. Coming to the next one, we need to specify the bug assumption. So bug assumption here is, whenever we are dealing with the strategies of processing these data objects, so what you have to do is nothing but, we need to specify, we need to consider each and everything for processing. Means we need to use not only the control flow graphs, and also we need to specify whether they have been used in a clear manner or not. How I am going to know? Here, I need to take a flow graph representation and I need to annotate it. I need to annotate it here. How I am going to annotate it here is, we need to represent or we need to process all these things in this presentation. Here, how I am going to allow this to be done is by using the control flow, that is data flow graph representation. Here the data flow graph representation uses data objects and its states and the usage of that one to be represented. So the data objects what we are representing will be specified in three ways. Means they could be defined, or they could be used, or they could be killed. Okay, so the usage what we are providing, the usage what we are providing could be CUs or PUs. CU stands for computation use, PU stands for the predicate use. Define means we are defining the variable, defining the variable. Kill means the object what we are willing to use has been killed, or we may specify it as a undefined one. Undefined one. So when we are trying to use an undefined variable, you will get an error that you are trying to use an variable which is not been defined earlier, or sometimes we will get that you define some variable and it not been used in at any cost, like that you are representing. So these are the data objects we are having, and we are specifying that one. Based on that one, we are creating anomalies of processing also, and we are mentioning the usage of here. So likewise I said, define means define, created, and initialized, or anything will come under the D. Killed or undefined, released. Usage means usage for the calculations, or if you are using in the control statements, is being specified as a that one. So based on these three, we have been taking the two character sequence of actions here. Means we will plot these DUK by two character. Means you can form anomalies which is being specified, specified by two characters, which has been placed like here. Okay, so first we should know what is an anomaly. It is an action what you are being provided. When you are using an anomaly, two character anomaly, what it means if it is KU, you have been killed one object, and then you are trying to use that object. If you specifying DD, you are define an object, and again you are defining the object, and you didn't use it that object without before redefining it. Okay, means for example, so there are the several possibilities of processing. So see this one, define DD. First one, DD means A equals to 1, and then next A equals to 2. So you define a variable, that is 1, and again you define a variable, that is the value is 2. So here you try to define a variable, or try to define the processing which is not used earlier. Then what is the usage of redefining it? So this one is being specified as a bug here. Means whatever you are defining one has to be used at least once. So what could be the usage here is, you can specify the usage as a C or P, that is the computation or predicate use here. And then next, define kill. So the next one, A equals to 1, and you kill that object. So here the thing is, if you are willing to kill that object, then why you need to create here? So here the thing is, it has to be whatever you are created has to be used. Same representation has to be used, whether it is in the C or P. But you didn't used here what you are mentioned, but it has been killed there itself. It has been specified as a bug here. So first two representations has been specified as a bug. And then coming to the next one. So next one is A equals to 1, and then n greater than A. So that is the statement I used. So here what I have done, been defined it, and I used it as predicate. So you define it and used it. So there is no such problem there. So what it is specifying, it is been specified as a normal case of usaging. Okay. And then next, KD means you unknowingly or unwantedly you kill one object and you try to define A. So here what it makes is, It is been allowed for further use. So there is no cause of bug here. So you have been created a variable which is for the further use. And coming to the next one, kill. So kill object, and again you are trying to kill same object. Been kill the object and you are trying to kill the non-existing one. So what happens here? It will arise your error. So what it is being specified that means whenever you are trying to kill or whenever you try to means delete a file which has been deleted, what it is being specifying, the file has been deleted, like that it will process. So that's one. And then next one here is the kill use. So here you've been killed the object. Okay, and then you try to use that object. So here what it is being specified, here the message will be no such object will be there, like that. Next one, so that is also probably a bug. Next one, use and define. Use and define means go further. N equals to a, sorry, n less than a, and later you are describing n equals to 2. So you've been used it as a predicate and you are defining it. So it's not a bug here because you have been allowed to define a variable at any point. And then next, use and kill. Use means n less than a, it's been used. Kill object what you are representing. What happens here? You should be sure about not using in future. So you should be sure about it is not being used in future. In future. And then next one, and then last one, use, and then next use. So use and use means you can specify this one will be used in predicate, or you may specify them it as a, sorry, you may specify it as a computation, like that. So whatever you have been designed has been used multiple times. These are the ways of processing or using your uh, anomalies here. So based on these anomalies, we have the flow graph representation. How we are getting the flow graph representation means we are processing based on the state graphs. State graphs, we are being specifying how we are getting into that. Means whenever we are, if you see here, these normal situations will not have any problem. If you get into these situations which are leading to a bug, then you will have to face a problem of anomalous here. Means whenever you are representing this in a state graph representation, what it is doing is it is allowing to take into the infinite state. So here we are having four such states to represent. One is for we are representing in the capital letters K, D, U, A, and we are taking the small letters when you are taking the action. So here K stands for kill, D is defining, U for use. Anomalous means whatever the states which are leading to the bug. Okay, so there are two such methods for processing. So the first one is the unforgiving data flow anomaly flow graph. So here what it is, once it has been get into the anomalous state, there is no chance of returning here. So first, from where I have to start. So consider here, I am starting uh, from where I am starting here is, take it as a define. So here, so where we are considering the define processing. So here specifying that whether I am defining whether this one has been defined or not. So it is being considered as a defined. Then what it is been doing, it is been specifying that the thing what you are using, trying to use, has been defined early. So from defining, I want to take into the further actions. So how I am going to take into the further actions means, so I need to do the steps here. So how I am going to perform the steps of processing here is, from define to, I need to consider what are the uh, things I can perform here. So from define to, so from define, what are the things I can do? If I am to redefine, if I am to redefine or kill, means how many there are three ways, or the three states are there. There are three transitions are there. So this one and this one are leading to the bug, and this is not a bug because whatever the defined one has been used, so it's not a bug. So why we are considering both the above or the bug means define and define. So you defined a variable and then you redefine the variable and you are not using it. Means what is the condition? Whatever the defined one has to be used once. It is not following such representation. What it is doing, it is being considered as a bug here. Define and kill means it is not been same situation. It is not been used once. That's why it is been specified as a bug here. And then next one, take the next one, which is u. So for u also, you have three transitions. One is d, and then next u, and then next k. Okay. So d means use and define. Okay, use one, you can define that, means you can redefine your variable, and what you are specifying, you have been used it, so it's not a bug. Okay, use and use, so you can use it as many as once, so it's not a bug. So probably it's not a bug killing, but you are having a chance of redefining it, then each and everything will not be considered as a bug here. So define and define means a equals to, sorry, use and define means a c equals to a plus b. Okay, there I am using a in computation and I am redefining the variable as a 3. So that is the first one. Next, second one is use and use. C is equals to a plus b, sorry, a plus b, and n less than a. Okay, that is the one. And then next one, C is equals to a. Be sure that before killing it. Okay, so these ways are not being considered as a bugs here. And coming to the killed object can be defined, so it's not a bug. If you are to, if an object has been killed, you are not allowed to use that one, that is a bug. If you are trying to already killed one, that is also a bug. Whatever the one you are being specified here will all be, will three here, two transitions, and then next here two transitions which are leading to the work here. Whenever you are entered into the anomalous state, whatever the transition will be, you will be stay in the anomalous state only. To overcome this one, we have been added several states for processing, and we have been designed a new state graph which is been specified as a forgiving data flow anomaly flow graph. Here we can recover from each and every one. Apart from creating one anomalous state, has been created three such anomalous states, and we have been providing that is a recovery from this one. How we are going to recover here is, see, the defined one. So if you see wherever you are getting, you have been reaching to redefining it. So from each and every state, you have been getting how to redefine the data. Means by redefining or the defining, you can use it, and also by processing that one also, we can specify that we can use such representations in such a manner. So here this states what you are been causing errors, so such states has been taken into the account, and they have been considered as an anomalous state which could be considered as a recovery. So here I will start with the define. So I've been using that one. I have been allowed to reuse that one. If it is been killed, I have the possibility of redefining it. Whenever it is been killing itself repeatedly, what you have to do, it has to consider as a self loop. So whatever the things we have been performed for the repeatedly is being considered as a self loop here. So here, whenever you are trying to kill the object which has been already it's not an existed one, it been returned to that state only, and it is been redefined there. So whenever you are trying to kill that one, means you are trying to kill that one, so define and kill. So then what you have to do, you need to use that variable. Means if you want to use that variable, then you will go for this one. Yeah, means it is an anomalous state. So what you have to do, you need to use that killed variable. When you are trying to use that one, what you have to do, you need to redefine it thing. So here I need to redefine the value, and then what I have to do, I will try to use that one. So likewise I am getting all these things to be done. So here, based on that one, I specified the data flow model. So the data flow model includes an example which is been taken into an account, that it is been study of the variables which is been taking, whether it is been performing the what type of the actions here. Means this is the program which has been seen in the previous unit. So here we need to study about what are the variables we are having. Means we are not taking arrays or the list side like representations, we are taking only the variables here. So here the variables will be x, y, z and v. Okay, so here we are considering the flow graph representations for this one. So this is the flow graph this is not the simplified one, this is the flow graph representation for that one, which is a simple considered as a annotated one. So if you go for the this one, means for example x and y variable. So if first see, x and y variables are input xy. Input xy means a defined x and y. I used x and y, and again I used x and y repeatedly before getting into the z greater than or equals to 0. D used here, which one? Computation use, C use. Again C use. That's why I specified D and C and C. After that, I didn't use it X and Y directly. And go for the Z. Z means, see here, see in this representation, Z has been defined at first, and it has been used as a predicate use. And then next go for the C use, and it has been considered in the predicate use. Likewise, what I am doing, I have been specified each and everything from first to last where it has been, means whatever the variables you have been designed, you have been processed, has been used successfully or not, we need to mention. For example, see this one, DCC. So you define the variable and then you have been used this variable at least once time, means throughout the program using it's not is possible or not for such variables, but you have been used it later there itself only. But constant to the z variable, what you are doing, you defined it, you used it various times as a computation, and you defined it, redefined it, and you have been used that variable in the predicates also. Likewise, get into the v variable, it has been defined here, and it is being used in the computations, and it is been not redefined, just it has been defined once only. And what it is doing, it is being used in the computation here. So and then what we are doing, we are using it in the predicate also. So likewise we are processing here. So it is not necessary that to redefine a variable or to use a variable continuously. So for what you have been designed, the variable means to use at least once. If it is achieved or not, we need to consider. If it is achieved, what we need to we need to see, we need to specify here. So how I am going to mark here is, so see here, this is the predicate, so I have been marked, this is the p. So between the 5 and 6, between the 5 and 6, at the 5, at the fifth node, so at the fifth node, if you go for the linked list also, z is equals to z plus v. What it is doing, it is being considered as a, it is being considered as a z is equals to z plus v, z is equals to z plus v. So it is being defined, first it is been computation has been done, and then next it is been defined there itself. So that's about today's class, ma. Thank you.